like this, where it says sketch, and the rational function might look like this. That's a ratio, it's a fraction. I hope I have everything copied down correctly. And press to graph it. Show us a picture. What does it look like? And we'll go through those steps, and I'll have those steps typed up for you on the exam Wednesday. And we'll go through step by step and answer each one, and try to put everything together and get a graph. Now guys, this one will have a different item on it that you have not seen before. Step one though, on those steps I gave you on a handout, I was asking for the domain. I would first simplify what was given to me. And guys, on top in my numerator, I can take out a common factor of x and have that remaining. In fact, when we continue, it will factor further into this. So there's the numerator completely factored. Yes or no? Yes. Look at it. Mm-hmm. Denominator will factor into this. Now, I do not want to make a mistake, and I'll write this down. You guys agree with that? Yes. Now, look what happened, which I think happened also before spring break. Does one of those factors cancel? Yes. This factor cancels out, leaving me, I'm putting it in red, this simplified version to deal with. You're going to be very careful. As I was telling my 4 o'clock session, guys, one of these is so busy, it could be worth 15 to 18 points, just this one problem on the test. Everyone's so far with me? Now, can anyone tell me, remember we're going to go through all the steps, can anyone tell me what happens, this indicates something's happening on the graph, if you see a factor canceling? A hole. A hole. So there's going to be a hole in the graph. And I know and you know, where is it, Professor, where's that hole going to be located? You take that factor, solve it. So the hole is going to be x equals -2. Well, I need 2 coordinates to find exactly where it's placed. So x is -2. Can anyone tell me how would I find the y coordinate? So I'll find the precise location of that hole. Plug in -2 back into your what? Simplified version. Just replace the x's by -2. So right here, guys, find r at -2. Easily done. Replace those x's by -2. Do not let me make a mistake. Do it quickly. Let's see if you guys agree. Replace an x by -2. I think I get that. All together, I think it's a positive 8 over a -5. Yes or no? I did it quickly. Is it 8 over a -5, you guys? Yes. Help me out. If it is, that's this. Write mine like this. There's the precise location of the hole on the graph when I finally get to it. Yes or no? Okay, don't let me make a mistake in the math here. We'll throw this thing off. Now, after all that work, you say, Professor, what is the domain? Now, I think on the handout it says they want the domain before this happened. They want it when you first did this right here, before you cancel something out. So can anyone tell me right here initially, what can x not be?
3 negative.
There you go. So x cannot be 3 -2. That's just step 1. Now, I know it's been spring break. Now, I don't think you were thinking too much about math 2 during spring break. There's 2 places here that x cannot be. Can anyone tell me, when I get to my grid and start graphing, what's going to happen at x equal to 3, which is one of those numbers that x cannot be? Can anyone tell me, when I get to the grid, what's going to be happening at 3? I heard something, tell me again.
Vertical asymptote.
That's gonna be a vertical asymptote. You said, Professor, how about -2? Now, this is the difference today. What's happening at -2? Because -2 can't be used either. Is there another vertical asymptote at -2? No. Yeah, that's where the hole is. So that's why I have two breaks. I got a vertical asymptote along with a hole there in my complete domain. I would think as a student, both these are vertical asymptotes. No, this came from the hole there for the domain. So guys, there's my domain. Number 2 says simplify the function. And if you don't mind, we've already done it. I'm gonna write like this. It's in the red down there. That's the simplified version. Now I give you partial credit for all this. Okay, step 3, if you look at your handout, I think I was asking for the intercepts. So the x-intercept, the y-intercept. Guys, to find an x-intercept, you set the function. It might be wise to use the simplified version, the red. So set that equal to 0. The simplified version, and I copied this down correctly. Looks like I have this. Quick cross multiplication, guys, gives you merely this. You guys agree? So far, so good. You think of this 0, 0, 1. Just quickly cross multiply. You get that. Set each one of those equal to 0. You got x equal to 0. X is equal to 2. I prefer ordered pairs. Written as ordered pairs. And those are my x-intercepts. Y-intercept, let's go back and find r at 0. In other words, go back and replace all the x's by 0. You do it here. What am I going to end up with if I go back here and replace x by 0? I think I'm going to end up with 0. You replace all those x's by 0 and do a calculation, guys, which makes sense. This x-intercept and y-intercept would have to match up. So far, so good. Partial credit, partial credit, partial credit for all this so far. Number 4. I think was asking for the location of the, I'll use initials here, the vertical asymptotes. Now, how does one find a vertical asymptote from that handout? Where are they located, those vertical lines that the graph cannot touch? Set the denominator equal to 0 in the simplified version. So you get x subtract 3, that denominator, equal to 0, and you get 3. If you did it back here, you'd pick up the whole also. Okay, so the vertical asymptote is only at x equal to 3 from that simplified version. Be very careful with that. Number 5. Here we go. Horizontal asymptote. Now, some of my students have done the research. They were telling me during the 4 o'clock session, says, Professor, I realized I was on a spring break. But no, I didn't forget Math 2 altogether. I started looking through some things and trying to find something that may help me. And they said, and I said last, or the week before, that if these two match up, the degrees of the numerator and the denominator, if they match up, that's the easiest case ever. So before I ask you what's going to happen on this one, where they don't match up, let me go on the side here. If, and when you start reviewing for the test, you'll see I use that 1 over x business from calculus to find that horizontal asymptote. If I did it here, which I'm going to do, and I'll show you a shortcut. Can anyone tell me what would I be dividing everything by if I use the calc technique to find where is, if it exists, where is the horizontal asymptote? Does anyone recall what would I be doing back here to find its location? About everything by the highest.
Yeah.
And what's the highest? 3. Is it? So if I divide everything by 3, right now at this point, everything by 3, the original. You got this, up on the side here, you got this, You got this. And do not let me mess up here with this marker. X over x cubed. And subtract 6 over x cubed. One of my colleagues was just showing me his exam he gave before spring break. He showed us some of the scores and what the test looked like. And he was asking them to do something like this. Just take the highest and divide everything through by the highest. And then simplify it. Guys, if I simplify this, please tell me, would I end up with this? That is algebra. And slow me down at any time. And I'll read that last term like that. Is that what I have if I simplify it? Algebraically. Here, well, that could be an x squared from algebra. And here, this and this, well, that could be 1 over x squared, yes or no? And then, better than that, may I rewrite it for a reason as this. Just rewriting. There it is rewritten. Now, can anyone recall why did I try to bring in 1 over x as much as possible? What is the limit as you make x get large for 1 over x?
0.
What happens if you take 1 over x, and think about just 1 over x, you don't need to visualize the graph of 1 over x. Just 1 over x, and you make this down here, the denominator, x get large. So you start out with maybe 1/10, then you go up to 1 over 100, then 1 over 1,000, 1 over 10,000. You're making that denominator approach infinity. What's the value becoming?
0.
It's becoming 0. It's becoming smaller and smaller and smaller and smaller, so it's approaching what? 0. So that means, with this statement right here from the calculus, right there, that all these may be replaced by 0. Based on this. Which I think leaves me, well, 4 times 0 times 0 on the top there is 0, of course. It leaves me a 1 there. And down here, guys, I got 0 times 0, that drops out. 6 times 0 on the end drops out, leaves me a 1 there. Is my, let me look up here, is that going to work out for me? Or not? Look at it closely. After spring break. Did we do it correctly? I see heads nodding, and I see a hand going up and say, Professor, you're trying to trick us here to begin with. Alex, go for it.
On the denominator, when you made like x squared over x cubed, why did it become 1?
Beautiful. What should it be?
Over
Right here from algebra, what should this be? I've seen that done before, that's the reason I did it. Should that be 1 over x?
Yeah.
And also I held off, should be 1 over x. Thank you. That's exactly why I did it. Now what do I have down here? Earlier I had what, 1?
Yeah.
Now I got what? Another 0 here. Is that true? Now what do I have all together here now?
Undefined.
Good luck. Does anyone accept that I do have 0? Then I have some students up here shaking their head. Yeah, Professor, I'm still on spring break. I'll just nod their head like this. Oh, I'll accept anything. 2 plus 2 equals 5, Professor. Today, 2 plus 2 is equal to 5. Does anyone see what I did? I set you up. Now, is there a 0 on the bottom there for sure? I can't divide by 0. So now, all of a sudden, I heard a student say, Professor, this is not this now. This is undefined. Which tells me there is not one of these. It's not working. I tried. it's not working. Now, I'm gonna give you a shortcut shortly. Now, number 6 is not working. Number 6 on your handout says, now consider, which we have not considered yet in this class. There might be not a horizontal asymptote, but something known as, look at this, an oblique asymptote. You say, Professor, what on earth is an oblique? I know what a vertical asymptote is. I know what a horizontal line looks like, asymptote. What's an oblique? You may have, look at this, guys, a slanted line that's acting as an asymptote. And we're going to stick with the lines here, slanted line, oblique asymptote they call it. Now, how can you tell right at the very get-go that there is one of these and not one of your horizontals that you're accustomed to? Go back, look at this. Did my degrees, where am I? Oh, here it is. Did my degrees match up as we were hoping they would? No. Is the one on top, be very careful, is the one on top exactly one larger than the one on bottom? If that happens, that leads me directly to, Professor, there's not this, there's one of these. Now, when does that happen? Only if the one on top, the degree, is exactly one larger than the one on the bottom. Not two larger, not three larger, we're sticking with just one larger. That tells you, beware, there's an oblique asymptote involved on this graph. So far, so good? Now, before I jump into it, I'm hoping, you're hoping Wednesday, when you get the copy of the test, you're hoping, Professor, please be kind to us. And maybe make this a 2. Please, Professor, can you make them equal? Because if they're equal, the answer quickly is what? This coefficient over this coefficient will tell you the location of the horizontal asymptote. In other words, you would have one of these then. Is that true? And it's merely this number over this number tells you the location. That's the easiest case in the world to work with. It's not working on this one because they were not the same. Now, one of my clever students, oh my goodness, she was asking me in the 4 o'clock session, she's doing her homework. She says, Professor, suppose this had been an x to the 4th and leave this as x squared. Now how large, much larger is the top compared to the bottom? 2. That tells me there's no horizontal, there's another type of asymptote. It's not linear. In other words, would x to the 4th over x squared simplify into x squared? And what does the graph of x squared usually graph into? Thank you. Would you believe you would have, if that happens, and we're going to stay away from those for now, you would have a parabola acting as an asymptote. The parabola is not the graph. It is out here somewhere on your grid. Look at this. You would have something like this going on. And she showed me what she was doing. Here's this. You said, Professor, where's the graph? The graph is doing something like this, maybe. It's sort of following that parabola. Now we're going to stick with no linear. For goodness sake, now they're going into the quadratics with the parabolas as asymptotes. So guys, if I stick with the linear, this one on top must be exactly one larger. And then you'll get a line called an oblique. Now, where is it? Well, the oblique, if it's going to be a line, not a parabola, I know the form should be looking like this. Is it true? Is that the standard, like a slope-intercept form for a line? So I need to find this, and this is going to act as an asymptote. Now, you guys who did your research, does anyone think they realize how to find this for this? So when I get to the grid, I can draw that straight line, and that straight line is going to be an oblique asymptote for my graph when I get into it. Shane?
You find M and B using the leading coefficients of
I could, I think your book may have suggested something else, but I could, I heard what you said. And I heard, some of my 4 o'clock session students told me, said they had looked ahead and said they saw something called something that we use here to find this line. Does anyone recall? I'm gonna go back to this, I think it's best to here. You gotta divide this in this. You gotta use long division. You gotta divide x subtract 3, watch carefully, into on top there, of course, is x squared subtract 2x. You gotta divide this thing out. And then remind you how to do long division from algebra. You ask yourself first, how many times will x go into x squared? Guys, that's the start of x. You agree with that? Long division. Then you take the part here, multiply your divisor, they call it. Multiply these 2 parts together, and you end up with x squared subtract 3x. Long division from middle school. Does anyone recall what you should do next in your procedure?
-5x.
Come again.
You like subtract it out.
You subtract. You subtract 2. In other words, changing signs. The first 2 terms will drop out, which they should. X squared. Negative 2x and a positive 3x will give me x. Now, how many times will we continue this? How many times will x go into x? 1 time. I take 1 times this divisor, 1 times x minus 3 like I did earlier, you'll get this. Everything lined up. Subtract or change your signs for long division. My x's cancel, and I end up with merely 3, which is known as a remainder. You guys agree? Did I do the long division correctly? Do we remember long division? Oh, that middle school field trip is coming up. Oh, I know they're doing long division over there. And it's just across the street. Oh, just a little short walk. You guys agree with this? Now, do I now have this by long division? Can I now write this as y is equal to, what was that, x plus 1? Yes or no? Are we okay? Or not? Does it look good? Is that the line? Awfully quiet. I think, is that the line that I'm gonna find, place on my grid, and let that be the, oblique asymptote? Yes, go ahead, Billy.
In the long division where you put x squared minus 3x, why did you change to a plus sign?
I did this, Billy, to try to find where I was here on the red here. I went ahead and multiplied this out here. I distributed properly that, so my long division would be much easier.
On the, underneath where you put, x squared plus 3x under the.
Oh, right here?
Yeah, why did you change it to a plus?
You subtract. After you get to this point here, for a long division, you always subtract. Let me remind you. Hang on, just 1 second. I know exactly what you're talking about. Guys, let's see. If you were asked to do this, I'm glad she brought this up. 25 into, let's say, that. That's long division. Isn't it? I hope they still teach it like that. Is that long division? And how'd you start? I think most teachers show them what, how many times will 25 go into what, 51? Is that the way you start here on this arithmetic problem? And I think you got what, 2 here maybe? Is that true? Then you multiply these 2 together. It's part of the quotient times your divisor. That's 50 in this case. And then what do you do next? You subtract and get, in this case, 1. Then you bring down your next term. There. And ask yourself how many times will 25 go into 10, and you continue. In this case, none. Is that true? 0. Is that true? So what I have for this arithmetic problem, what, a quotient of 20 with a remainder of 10. I'm doing the same thing down here. I'm using the same procedure. Yeah, did that help?
Yeah, I was used to having 2 terms when doing long division.
Sometimes, hang on. Look at this. I'll make up one real quickly. We may not go through all of it. it may do this. Let's hope it doesn't. That's long division. Is that true, guys? Don't get me started on long division here based on the elementary school or middle school problem here, or what we did earlier. Ask yourself how many times will x going to x cubed? X squared, that's the start. Look at this, really, I'm glad you asked. Then x squared times this divisor would give me x cubed subtract what? 4x squared, yes or no? Next step in the long division is to what? Subtract, which means change the signs. First two drop out and we end up with a negative x squared. Bring down the next term, I gotta continue. Bring down my 2x, start all over. X into a negative x squared, help me out guys. Negative x. A negative x times this divisor, a negative x times x would be a negative x squared. A negative x times a negative 4, what's that, positive 4x? Beautiful. Now change the signs again, in other words subtract. Plus, change that to a minus. X squareds cancel out, which they should. Looks like we'll have a negative 2x, and we're down space down here, negative 2x. Bring down my last term, subtract 6. That's finished. Now x into a negative 2x, what's that, negative 2? A negative 2 times that divisor will be a negative 2x. And guys, what is that, minus 8 or plus 8? Plus 8. Is it? Change your signs for the last time. That's like your subtraction. And these two cancel out. You got a remainder of, if I have no mistake, a negative 14. Yes or no? Lord. Long division. That's what has to be applied if you have sense right quickly that you're supposed to have an oblique asymptote and you got to use long division to find where it is. Okay, see hands going up, Bella.
What I don't understand or I don't remember is what the remainder means.
Ah, beautiful. The remainder's going to drop out. You don't have to worry about, well said. You don't have to worry about the remainder. Bella. I know Bella by now, she's a good student. She said, wait, Professor, how about that remainder hanging on? Does that have any effect? Let me do this. Could we, even from middle school, could I take that 3 back up here if I wish and write it over my divisor? You guys remember doing that? Let's see, like here, could I write 10 over 25? You remember doing this, guys? If you wish. Could you take whatever that remainder is and put it over that divisor? And write like that? Bella, if I did here on this one, for example, and then you applied this one over x business I'm talking about, this is going to drop out to a 0.
Oh.
So that remainder, when you finally get that remainder, you need not worry about it any longer. Whatever that remainder looks like down there at the very end, when you finally have to stop, you need not worry about it any longer. So far, so good, guys? Whew. Now, where am I? The oblique asymptote, we finally named this one as what? X plus 1, was it? Now, I went through some other examples. Ignacio, I don't want to put you on the spot here. We usually ask ourselves at this point, if it's a horizontal, is there a crossover point? Because I think the handout you just received, you received there, I think it was a crossover point. Ignacio, believe it or not, your graph could, I don't want to mess this up, could cross over not only a horizontal, it could cross over an oblique. Can you tell me how on earth would you find, before I get to a grid here and start graphing all this mess, is there a crossover point of my graph with that straight line acting as oblique asymptote? How can you tell, can someone tell me how would I find it if it exists? Shane.
You would set the, the equation for the oblique asymptote.
X plus 1,
equal
set
to
that, equal to what?
the equation for the, graph.
This, and try to solve it. If you can solve it, there is a crossover point. That's the same procedure you use for a horizontal crossover. So let me go write this as x squared subtract 2x up there over x subtract 3. Guys, if I can solve that, there's a crossover. do a quick cross multiplication. If I cross multiply, guys, we end up with this being multiplied together, that's algebra, will give me x squared minus 2x minus 3. That's this times this. The other direction, those two will give me this. Yes or no? I just did a quick cross multiplication on this, trying to find the crossover point. Now try to solve this. Well, on this one, look what happens if you attempt to solve it. Will the x squared cancel?
Yes.
Will the two x's cancel?
Yes.
I have no x's left. So there is no crossover point. So I need not worry about a crossover point on the oblique on this one. Wow. Woo! Oh, by the way, did we have a hole on the graph here? Okay, so number 7, let me go put the hole down here so I won't forget it. And we said earlier the hole was, where on earth was it? -2, -8/5. I don't want to scare you. I'm gonna give you plenty of time on the exam on Wednesday. I am telling you, as you watch your instructor do all this, I guarantee you some of my students would sit here 2 hours. I probably, as a student, would sit 2 hours. One of these could require 2 hours. Because you've got to be so careful. This asymptote, that asymptote, there's a crossover point. Where are my x-intercepts? Where are my y-intercepts? Then all of a sudden you try to put everything together and it doesn't quite match on your grid. Okay, guys, look at this. It says sketch. Where's the sketch? I'm over here on the other board. It took all that to lead up to the sketch. We haven't sketched this thing yet. Are we okay with all this? 18 points probably for one of these. I'd say 15 to 18 points for just a rational function. One problem on your test Wednesday. Shane, go ahead.
So, just to backtrack a bit, when we were looking at the y equals mx plus b, and we did the whole mess of long division,
Absolutely.
it was, do we have to do that? Because technically we can get it through y equals,
mx plus b.
well, yeah, the leading coefficient of the denominator as n.
Now, if you, I understand what you're saying. So if you have another technique that you think might work, go ahead and use it.
Yeah.
Okay, I use long division there.
Okay.
Okay, but if you see another technique, go for it.
Okay.
Are we okay, guys? Now, if I should ask right now, I doubt any student in class, even though I've got some really super students in this class, I doubt, here's the original function. I want its graph. And to get its graph, this function's graph, I gotta use all this and place it on the grid. Now, is it gonna turn out to be a circle? No. No. Is it going to turn out to be a cubic type graph? I see a cubic involved here. No. These rational functions will drive you nuts. Okay, let's put all the pieces together. Guys, number 1, of course, is the domain. I'll skip that. Number 2, simplified. I'm going to go down to number 3. On your grid, place those x-intercepts. I see 0, 0. And the other was what? Was that -2 or +2? I think it's +2, was it? That. Those are done. Tons of partial credit here. Vertical asymptote number 4. You better go out to 3 and show me that right now. And that means we have one of these. I'll place this in red to show you cannot let the graph touch that. Horizontal, none. Oblique, oh boy, this is a strange one. Try to put this in blue. There is an oblique. I gotta graph this. X plus b, or you can find the x and y intercept. Oh, wait, guys, can anyone tell me the x intercept right quickly for this one? You said x plus 1 equals 0 and solve, you get -1. So this thing has an x-intercept at -1 and a y-intercept at 1. That would help. So let's do this. Let's go to a -1. And this is the blue. y-intercept, and we said the y-intercept was, I'm gonna go back where I am, 1. Go up to here, and mark this. Straight line. That's the only type of oblique we're dealing with in this class. Guys, here it goes. That in the blue is an asymptote. The red, where's my red marker? The red is an asymptote. There are 2 asymptotes. A slant or oblique asymptote along with the vertical asymptote. 2 asymptotes to pay attention to. Am I finished? I don't think so, because we said there's also what? A hole in the graph. Now, -2 down what? 1 3/5. The guys, -2, my goodness, -2, is that like, don't really make a mistake here. Is that over here? The truth? And down what? 8/5, which is what? 1 3/5?
Yeah.
Can someone please in this class tell me, if I plot it, do you think it's gonna fall below that blue line?
Yeah.
Or it's gonna be above it?
It should be above it.
Oh, wait. So it's gonna be above the blue line or down below, down here or up here? Okay, how would you find out? I would plot, or -2, I would quickly put -2 into my oblique, the blue. If I put -2 in here, guys, I get -1, don't I? So that means, right here on the blue, this is now -1. Yes or no? We're looking for what though? Down 1 3/5, it's below on this. So that's the hole on the graph. And let's see if I have another marker that may work. You talking about madness? You get one of these on the exam, correct? You're good. Right there. That's what we represent. Out -2, down 1 3/5. Whew. Okay. Now look back at all the information I have on the sideboard there. I think I've used all my information, have I? Does anyone see anything I've left out? We're ready to graph it. We're ready to graph. You say, Professor, my goodness, that's not the graph there? No, I don't have a graph yet. Yes?
Is it -2 minus 1 to?
This is -2 and -1 3/5. I think it's -1 3/5. Was it, guys?
Yeah.
Right here. A little hard to read here. Yeah, -1 3/5. Okay. Now, how many sections to this graph will there be? It all depends on the number of vertical asymptotes. I have only 1 vertical asymptote. So something's happening over here to the left of it, and something's happening to the right of it. There's only 2 pieces. Does anyone think they know what the shape is to the left of that red vertical asymptote? Alexander says, Professor, I think I know what it is, and you've got asymptotes to follow. Alexander, describe, and I'll do it. What do you think this piece out here looks like?
It would be going,
Does it have to follow this?
yes,
Okay, hang on. Does it got to pick up this point here?
Yeah.
Thank you. Does it cross over?
yes.
Let me make this a little better. It's not through here. Come up, cross it over. How far up? We don't know. Come on, marker. And then let's come down and follow the vertical.
Yeah.
Wow. Guys, does it look something like that? To the left of that red vertical. True? Now, to the right, it's going to be cute. To the right of the vertical. Now, you got choices. I'm going to show you some choices. You can plot points. You can always plot additional points. One possibility, I've had students say, Professor, could it do this on the right? Like that, and up, and follow like that. No, because it will cross the x-axis. And there is no x-intercept over there, so it cannot do that. Well, the only other possibility would be to follow those asymptotes, which I think is, on this particular graph, cute. Look at this. And you want points to make sure, is it going to be doing something like this? Is it following the asymptotes up there in that little corner? Ooh. There's your graph. That's a picture of that back there. This. Where is it? Back here? Yeah. This right here? That's a picture of it. That's a graph. Look at those faces like, oh, a day after spring break, Professor, are you kidding? Jeez. Now, could you do something like that for me? We're about to prepare for this. Okay, now when will this happen? With an oblique? Only if on the test you see this happening. You check it out, and you say, oh, Professor, the degree on top is exactly one larger than the degree on the bottom. Then you're in trouble. You gotta use long division, you have to do all this business, and you have an oblique. The easier one will be the one I gave you for the handout today. If these two had matched up, then you have a horizontal, not an oblique. Now see.
Does anything happen if the degree on the bottom is bigger than the degree?
Ah, beautiful, beautiful. You said, wait, Professor, you told me all about what the others were. Suppose this happens. You're telling me maybe, I'm trying to think what you did here. This down here might be that. Now check out the degrees. The degree on top is 2, the degree on bottom is what, 3? Where's the larger one this time? On bottom. What do you think will happen now? And some of the students know, because they were telling me in the 4 o'clock session. Where's the horizontal asymptote? Is it going to be an oblique? It can't be an oblique. I switched the order there for Ignacio. Where's the asymptote located this time? I see hand. Shane.
It's at 0.
It's at 0, which is the x-axis. So that case should show up. It's the x-axis acting as what it is. This axis acting as your horizontal asymptote. Wow. Okay, now am I finished with this? No. Let's go up to 20 points. You got the graph, and you're happy to just get the graph. Now you got questions on the side here. Question number 1. Find the limits as x is approaching infinity of this function, it's called r of x, based on your graph. Okay. Let's do a translation. You're making x get large. I know the x-axis. This is the x-axis. I stopped at 3. Now it says keep going forever. This is x approaching infinity. And you're going to drag that graph along with you. As you drag that graph along with you, which is up here, can anyone describe what's it doing? Is it going higher and higher through infinity? You guys agree? Let's check the other end. Limit as x is approaching negative infinity. You say, Professor, now what's happening? I stopped at -2. Now you keep going. This way this time, forever. And pull that graph along with you, here's the graph. As you pull it along with you, where's it going? Negative infinity. It's dropping down. Number 2. Let's find the limit as x is approaching 3 from the right. Superscript of a positive sign. Not 3. Is it 3? Yeah, 3. So approaching 3 from the right. Now, which piece of that graph is to the right of 3, but close to 3? Is it this piece here?
Yes.
Is that piece close to 3 and on the right? What's it doing? The closer I get to 3, is that graph rising?
Yes.
forever through infinity? Here's the answer. Sorry, one more. Number 3. Time limit. As x is approaching, what did I put it for you? 3x. Now, have x is approaching 3 from the left. I think you know what's going to happen here. Guys, 3 to the left, is this piece right here to the left of 3. Please describe what's it doing? Negative infinity. Wow. Now, if your instructor took that much time to just do one problem, it's going to take you a good 2 hours to do this test Wednesday. A good 2 hours. I've got some students who may take 2 hours on this one problem. I'm hoping not. Guys, look at it closely. Any concerns? Okay, Alexander.
Why wouldn't it be, for the first one, wouldn't it be the,
Okay, this one right here,
yeah,
and
why
x
would,
is large.
why wouldn't it equal the oblique
I
aspect?
love that. I love that. Look at this. I'll accept this answer here because it is rising, the graph, the black graph. Is it going up like that as I go out this way? So it's infinity. Alexander says, Professor, could I not also say it's getting closer and closer, the black graph, is it also getting closer and closer to the blue? Is that true, guys? It's still getting closer and closer to the blue? And I think the blue, its name was, that was the oblique, wasn't it? Where is my oblique back here? Somewhere. X plus 1? She says, Professor, could I have written this as, look at this, Alexander, a mathematician. I'll give you quotes here. Isn't it also approaching x plus 1? It is. I could not count that wrong if you put x plus 1. Bella, what do you think about the same thing maybe?
No.
Oh, you got your, okay, you got another question. What's the other question?
How long are we gonna have to do?
About 2 hours,
Okay.
maybe a little bit more. Because you guys keep in mind the exam covers not just this. Yes,
The one under the x plus 1 thing?
what's that?
For like the one under we just did, would it also be fine to put x plus 1 instead of negative infinity?
Wait, I'm trying to find where you are.
Like, limit x to negative infinity?
Oh, this one down here.
Yeah.
Okay, this right here. And we said it's dropping down forever.
Yeah.
Okay, negative infinity, right?
Would it be fine to put x plus 1?
Beautiful. Beautiful. Is it also approaching the blue x plus 1? Look at that. No wonder our students are going to Berkeley. Absolutely, it is. Now, last thing I want to ask you here. Thank you guys. Number 4. Suppose I ask you to find, now watch carefully, R at 2,935. If I saw that as a student, I'd probably would freak out and go, what on earth? I don't know. I know what it usually means, Professor. It means you usually take that 2,935 and put it back here and crunch it out. Is that true? That's what it means. No. Can anyone tell me what do I want you to do at 2,935, which you know is way out here on the X? And Alexander just told me the further I go out there is my graph getting closer and closer to the blue. Would it be better to replace that 2,935 into this rather than, where was it? This. And say this is going to be approximately, what is that, x plus 1? Just add 1 to it. Approximately, what, 2,900 and how much? 36. That's your answer. You don't trust that? Take it back and plug it in. crunch it out. If your answer is not close to that. Okay, guys, any concerns here? I'm looking at the clock here. We start class at what time? 5. What time is it now? 6. 1 hour on one problem. Now, do I have time to do more? No. That's the last of chapter 3. That's another rational function type. Plus, you have a handout with another one done for you completely for some practice I gave you. If you did not receive that handout, I'll get a handout to you. Guys, we'll erase this. Any concerns here? Nah. We'll erase it. Okay. Now, this, when you leave class on Wednesday, after the exam, every semester, it seems like my students, they'll talk about the test outside class, and they'll start saying, oh, you got this? I know, I got it up here. Oops. You got that here? Yeah. What'd you get? Oh, I got it up here. Whoa. Every test, when I give a rational function, there's so much going on. If it took me an hour to do one problem myself, it's going to take some time on one of these. All right, guys, if I'm finished with it. I think we did a pretty good job on this, did we? Make some sense of it? Okay. Mr. Park, you have all this recorded for us? And by the way, my students are watching the recordings.
Nice.
Yeah, that's helping. Okay, guys. I got 10 minutes. All this done. Guys, please don't leave this class, not after all this hard work we've done. Now, I mean, me, Mr. Park, Susan, the class, those 4 o'clock sessions. Don't leave, and then for some reason, mess up on a math 7 test. Because I will find out. I found out today. One of my former students didn't do as well as the student had done in math 2. And all of a sudden, I see something, what? So I had to talk to them. I saw the student. I just want to talk to you. Just chat a little bit. Oh, Professor, how you been doing? Oh, come on in, I'm doing fine. Sit down, I want to talk to you a little bit. You should be on the top of that math 7 class. With that said, before my time does run out, guys, we'll call this part 2. I'm going to close this down with this. The composite functions. Now, I did some of these on the last class we had. And, if I'm not mistaken, let me check for sure. I did. Hang on just a second. I wrote myself a few notes here. Beautiful. We'll give you 2 functions. We'll call one f of x. And it looks like this. G of x is given to me as this. And I'm going to ask you to find things like this. Find the composite, little circle there, of those 2 functions with respect to x. Then I want to turn it around, find the composite. And number 3, find the composite of g with g of x. Beautiful. And then we'll take a break. Whoa! Now, if you have not looked at your notes at all, did not look at your textbook, did not do much of anything during spring break, I'm hoping you did. Help me out here. Guys, by definition, the F circle G is called a composite. definition says to find what they want, put it in blue here, they're asking to find this. F of g of x. Now, g of x was given to me as a square root, which is okay. And I got f on the outside of that. That's what it means to do. Is that true, guys? Now, what does that mean to do? It means to take that strange square root back into the f function. This up here. It's going to look strange. If I take that back to that black f function, please tell me, will it look like this? Yes or no? Give me a response. Yes or no?
Yes.
Now, in this case, some students may say, Professor, I think you could simplify that and make it look like this. See if you would agree. Could it be written like that? If I wish. Could I call it the fourth root? You say, Professor, how? Because this inside here from algebra could be expressed as the square root raised to the 1/2. Of course, on the outside, I know the larger square root raised to the 1/2. Multiply these two together, 1/4. Fourth root, if you wish. That one's done. Except, I'll be asking on the exam on Wednesday. Don't stop there. Now tell me its domain. Now, before I jump into the domain, the way the test is constructed, I'll probably ask you to find the domain of the original functions to begin with. Let's go back to the original. Anyone tell me right quickly, what's my domain on the f function, square root x? X must be what? Greater than or equal to what? 0. The domain on the green, the g of x, the green function here, the part inside there must be also what? Greater than or equal to 0? Or square root? That's true, guys? We're trying to find the domain. Solve this. Be careful. And please tell me, do I end up with x is less than or equal to 2? I did it quickly. Yes or no?
Yes.
So here's my domain on the f function. There's my domain on the g function. Now the question now is, what's the domain on this thing? That was the composite. Where am I? F circle G? Right like this. Now give me a start. What's the domain of my final answer? And by the way, it came out to be a fourth root. So what should that part underneath there be for a fourth root to exist? What should this be? Are there any requirements on that?
Greater than or equal to
Yeah, the 2 subtract x for a fourth root will make no sense unless that inside part is 0 or higher. You can take the fourth root of a negative number, which implies this. Now watch my symbols here. Is it that? The truth? Now you may say, Professor, I did what you said. I found the domain by considering this to be this, which it is. I solved for x. X is less than or equal to 2. But you have one more condition here. Where did this answer come from? It came from me placing this to begin with. Is that true? Did this have a restriction? If it does, I better take note of it because I could not have done the problem. That's this one up here. What restriction did it have? X is what? Less than or equal to what? 2. I got to throw that in. Does that, I agree with the answer I have right now. This is my complete domain on that. Now let's find the next one. Next one says G circle F. Guys, here goes. This means G of f of x. To find these is fairly easy, which means f of x, f of x was given to me as this, and you're asked to find g of that. Okay, now I'll do a little erasing here, get some room. Okay, hold off now, I'm gonna erase this, guys. Get some space, we did this one, finish. Now this one down here, it says take square root x into my g function. Guys, my g function is here. Can anyone tell me if I take this into this, what does it look like? Square root of what? 2 minus? Look at that, you know that string? That's the answer. The composite's done. Now the tougher part is this. What is the domain of that G circle F, that where that answer's staring at me? What is the domain? Can someone tell me a little technique I could use here to try to find the domain? What's acceptable for the x's? Anyone have an idea? This is the answer. What am I allowed to replace x by? Any number I wish? I tell you right now, I can replace x by 9. That would be 2 subtract what? Square root of 9 is what, 3? That'd give me a negative 1 underneath that large square root. That's impossible. So there's some restrictions. How would you find them? Help me out.
Were the two domains overlap?
No, something else. Let's just look at it and tell me a little technique I can use to find the domain. Start out with trying to find the domain on that strange answer. See, is there a large square root outside? Therefore, this inside here, for that square root to make sense, exist, what must that be? Greater than or equal to 0. Or you could not do that large square root on it. So the first thing I would take note of is that inside part, for it to make sense, must be this. You guys agree? Let's solve for x. We're about to have to take a break here shortly. We gotta just move 2 over. Multiply both sides by a negative or divide by a negative. And we end up with square root x. Do not let me make a mistake. Symbol reverses a 2. Yes or no? What would you suggest at this point to solve for x? Square both sides. And guys, if I square both sides, square both sides, we end up with x is less than or equal to what? 4. Ignacio, I'm happy if we're going to start scoring papers to see that much. But I got to keep in mind, is there more to this than that, Professor? Well, I got to keep in mind, to get this answer, right here, I placed that into something to get that. Is that true? Was there a restriction on that to begin with? Back up here was. I got to consider that also. Or I could not have done what I did. So besides x is less than or equal to 4, I must also put a comma here and say, hold on, and put it in blue. X must be also greater than or equal to what? 0. Oh, we're having fun. Now, can anyone tell me in interval notation, what's my complete domain in interval notation? 0 up to 4. Inclusive?
Yes.
Okay, so here we go. There's my domain. You get outside there, and you try this business I just did here, something's gonna go wrong. So there's my domain for that final answer. Last one, yeah, beautiful. G with G, that means G of x. G of x was given to me as this, square root 2 minus x. That's G of x. So I'm going to get right back into itself. Now this one's going to be strange. Anyone tell me what that would look like, taking square root 2 minus x back into there? Square root of 2 minus another square root of what? Now you're talking about strange, but that's the answer. Now the domain, that's where you may mess up. I'm running out of space now, guys. Domain on this one, oh boy. That large square root, the big square root, would not make sense unless the part underneath there, again, is this. Yes or no? That true? Solve it. Move that two over, divide or multiply by a negative, reverse your symbol, do not let me make a mistake here on top of the board, and then do what to this one? Square both sides. Guys, if I square both sides, we end up with 2 subtract x, that's equal to what? That 4? Help me out. Or a negative x is less than or equal to what, 2? Yes or no?
Yes.
Or x is divided or multiplied by negative, x is what? Greater than or equal to what? Negative 2. We're talking about the domain on this thing. Now, Alexandra, that's beautiful. But I gotta keep in mind, must I add something else to this? Maybe not. I gotta look back and see how this was formed. I was using this function to put into the other function to get it. Was there a restriction on this function?
X is less than.
X is what? Less than or equal to what? 2. I gotta consider that also on the side. Now, before I take Bella's question, can someone tell me in integral notation, what's my final domain? Wow.
Reduce 2 to 2.
Negative 2 up to 2. You get outside that domain, something's gonna happen. Wow. Is this a little easier than rational functions? Isn't it a little easier? I'll just give you some strange square roots to work with for my example here. I'll give you a hard example to look at. Okay. Now, Bella, what was that question?
How come we're only considering the restrictions of the function inputted and not the one that?
Beautiful. You're saying, Professor, why do you always just go back and consider the domain of this one? That true? The inside part?
Why not both of them?
Ah, beautiful. When I do it for both of them, that's gonna be the domain on that final, where was it? That's gonna be like saying this. That's actually both of them put together. But then I gotta wait now, I could not have done this unless I placed this, which had a restriction to begin with, there, attach that to my answer. To show I could not have done it.
No, but like when you do the fog one, are we considering the restriction of the f of x function and the g of x?
Ah, beautiful. Okay, I'm trying to find here. Fog, yes? This one right here.
Yeah.
Okay, I had to consider the restriction on this immediately. You could do it immediately, and that was, we did up here, what, x was what, less than or equal to 2?
Yeah.
That's true, guys? And then go ahead and finish it up, get the answer, and my goodness, I forgot that's all over the board here.
Oh, I see. Okay, I understand.
You understand now?
Yeah.
Okay, then go and look at the final answer and see if there's added restrictions. Woo! Okay, part 1 of the test, rational function. I'm not saying necessarily it's in that order, but one part of the test is rational function. Then all of a sudden you get that and you're wiped out and you're tired. All of a sudden, part 2, composites. And then the domain. I just have 2 of those, 2 problems to look at. I think it's only 2, or 3, or 4. That's be another part. Guys, I know it's time for a break. We're gonna wait. You're gonna pick this up at the end of class, not this. Is this it?
Oh, it's this one.
Oh, that, hang on. What's this? Did someone leave this here?
I don't know.
Was it here when I walked in? Oh, anyway, I don't know. I'll look at it. I'll look where someone left it. Just hang on, Mr. Parker. So guys, we're gonna get that to you before you leave tonight, because I think you might need those 6 points. You might need those 6 points. You talk about commending you. If I have a student, you get a perfect score on the test itself. I mean, you don't miss anything. You get that rational function just right. You get these crazy composites just right. And you're gonna get some other parts here shortly. Just right. And then you got the 6 points. Wow. Then you're gonna be doing well. Okay, so guys, I'll have this, we're gonna turn this in on Wednesday, I'll let you know more about it. Let's go ahead and take your 10-minute break, cause you're wiped out by